Hello, team. Hello, team. I think I'm live. Please let me know in the chat if you can hear me. I'm just gonna trust that I am live. And I'm just gonna switch over to my Desmos task that I wanted to show you. All right. So, let me know if you can see this screen, and I'm just gonna go full screen, just to hope this works. All right, so these are the same graphs as yesterday, and what I wanted to do was I wanted to have a discussion about fit. Okay, and the way I want to do this fit conversation is by modeling again, and then I'm going to talk about where a good fit is and where a bad fit is. So it might seem like a bit of a rehash of last week, last video, but I think I can cover a few cool points. Okay, so let's go into here, and I'm going to model a parabola again. X minus m, x minus n. Can you please just update me and let me know if you can see the changes that I'm making on the screen? And if not, I will have to change what I'm doing. All right, and so I'm going to just skip ahead, and I'm going to go one incept is 0 and the other incept is 100. You can ask me questions in the chat if you'd like me to go over something again, but I'm hoping that because we did this yesterday, you're going to be able to be a little bit more comfortable with what we're doing. So I've picked my two x-intercepts, and now I'm going to make my gradient a negative number, or not my gradient, my k-value a negative number. I'm going to start with negative 0.005, okay? And I'm going to just change this to projector mode, and I know I shouldn't use red, but I've just zoomed in, and I'm going to change this color to black so we can see it a little clearer. No, black doesn't work. Let's try orange. Yeah, orange I can see a little bit clearer. Fantastic. Okay, so what I want is I want to fit this model over the top of this bridge. And so I'm going to try and change how I do my numbers so that I get a good fit. So I'm going to change it to a 6. And look, it's quite good. And in all honesty, I'm probably quite fine with this. But what I'm going to do is I'm going to check. And how I'm going to check is I'm going to type in f of 15. Okay, but why I want to type that in is if I type in f of 15, it's going to tell me my function's value at 15, which is 7.65. But the green dot is going through at 8. I don't have to go through the green dot, but it kind of gives me an indication as to how far off this is. And so if I made a model that right, suppose that was my model. Okay, I can be comfortable that that model goes through 0, 0 and 15, 8, and the fit of this model is really good here. But do you notice that the fit of this model, if I zoom in a little bit, is getting worse in here? And so when I talk about fit, once again, I could look and see, no, it's actually not great in some of this area. But once again, I can just type in f of 80 to see what my 80 value is, and that's pretty close. And so for me, I don't want it to just go through those points. I want it to be a very good fit. And so I'm not going to necessarily be okay with this. Okay, but what I will do is I'm going to just go down back to here and just say from this, my model, nope, that's a bit zoomed out. I would say my model has a very good fit from x equals 0 all the way to x equals 100. This parabola model has actually done quite a good job. And I can also be sure of this because if I change, I'm going to just change this to a 3. Okay. I can also see that the fit is quite good at the points because look, at 15 it's meant to be 8 and it's 8.03. At 80 it's meant to be 10 and it's 10.08. And so even though it's quite bad in the middle, from this part to this part is really good, and from this part to this part it seems quite good. It goes off a little bit in the middle. And so I might write a statement like this. The fit of my model, I'm going to write parabola model, is very good from x equals 0 to x equals, let's say, I'm going to say it's very good until x equals about 22. And from, well, I reckon it looks pretty good from x equals about, that's not 22, that's 24, sorry. And I reckon it also looks quite good from about 74 to 94. And from x equals 74 to x equals 94. Okay, and why is that? Okay, so if I write that, that's cool, but I've got to give it a because. My because is because my model follows the roller coaster, maybe that's a 2-word one, roller coaster, very closely. Okay? That's a good fit statement. Right? I might also say between x equals 24 and x equals 74, my model seems to be too high or overshoot the roller coaster. This is a bad fit. Right? Actually, in this model, it's probably quite a good fit overall, but I mean, parabola works really well. When we get to cubic, I'll talk to you about good fit and bad fit. Okay? But I think that's pretty cool. So these two kind of statements are really good achieved sentences. But an excellent sentence, or a merit sentence rather, a sentence does all of this, but also gives me specifics. So this can be seen when x equals 15. Because, that's not 15, sorry, I meant to type 15. Because my model has a value of 8 point y value of 8.035325, and the roller coaster goes through at 15 at 8. this is a difference of only 0.0325. A very small gap. Alright, adding a sentence like this takes the fit comment from being quite bad to being quite a solid mirror idea. And what we could do is we could do another one. We could look at 50 and the roller coaster. It's a bit harder to find out. Okay, but you could also see that's quite good like that. And actually, because this model of the parabola is so nice, I'm not going to write much more. I quite like this, and I'm going to leave it as is. So what I'm going to do is I'm going to try and model something that's probably not going to fit as well. And let's see how that goes. Right, so you could type this all in here. Remember, write your properties and your fit, but I don't mind because I want to show you the graph and the writing at the same time. So let me try to do a cubic model, and we'll see if I can get a fit that's good. All right, once again, parabola cubic is kx minus m. And if you have questions, just sound out in the comments, please, in the chat, please. That'll be wonderful. Actually, can you just type in the word cubic into the chat so I can actually tell that you're listening? Thank you. And I would like everyone to do that. That'd be awesome. Okay, so for this model, just like I did yesterday, I'm going to make a 0 and 100. And I'm going to make P 200. Doesn't need to be, but that's what I feel like. I'm going to make this very small, 0.009. It's still too big, 0.9. Still too big, 0.9. Oh, wow. So what I could say is the model. I'm going to turn this to projector mode. I'm going to make that orange so you can see. My model's pretty not great. Thank you guys. That's awesome. You know, that really helps me because I thought I was talking to myself for a little bit. I'm going to just make this smaller. Okay. And this is the model I'm going to stick with. And I'm going to just type in f of 15 and f of 80. Because this is just telling me my function's value at these 2 points. Okay? And as you can tell, does it have to be very detailed? No. Monique, I'm not asking for it to be super detailed. And as you can tell, it's not a great model, right? And that's why I'm like not worried. But let's just see what I write in here. I'm going to write the fit of my cubic model is very good from, let's see where from, and I'm going to say about there. Okay, and remember this cubic model is a lot worse than my parabola model. My parabola model was almost perfect, and that's why it was really hard to pick apart where it wasn't good. From x equals 70 to x equals 100, outstanding. This is because, you've always got to give me a because. My model follows the roller coaster very closely. Okay, and it kind of does, right? From there to there, it kind of follows it. Sure, it's off a little bit, but I'm not as worried because there's a huge gap over here, right? Remember, you're meant to be doing your properties, but I don't want to talk about properties today. I'm talking about fit today. So it's really good from here to here because it follows the roller coaster very closely. However, from x equals 0 to x equals 70, my model has a bad fit. This is because the roller coaster and my model have a large gap between them. Okay, so writing something like that would give me an achieved kind of answer. Okay, but to add on to my achieved kind of answer is a note that would be, so I have to have this, but what I want to add to it is say this can be seen because when x equals 15, I'm going to just pick this value because I have that point. It doesn't need to be 15, but when x equals 15, my model is at 11.79. I'm going to just write 2dp there. My model is at 11.79, and the roller coaster is at, sorry about the crunkling, 8. This is a difference of 3.79, which is a very large gap. The good fit, oh sorry guys, my keyboard's been weird. The good fit can be seen quite clearly because when x is equal to 80, my model has a y value of 9.6, right? And that I can see from here, or I can follow my model along. And so if I click on this and I look, when x is 80, that's 9.6. And the roller coaster goes through at, why can't I spell model? This is really weird. Goes through at 10. This is a difference of only 0.4, which is quite small. Alright, sorry about the typos, guys. Alright, so can you sort of see that my model is really bad here, but it's quite good here because it follows along? And that's what I'd say. And is this the best model in the world? No. But is it a model? Yes. And I've described where it fits well? Yes, it fits well here. Where does it fit badly? It fits badly here. But there's a gap here, and I'm going to use this point as a marker. I could use some other point, but it's really hard to tell what the value is at that point. And so I'm going to use this point because I know it, and then compare it to here where it's at 11.79, and that's quite far. Whereas over here, at 80, it's only 9.6, which is quite good, but also kind of follows around over here. It's pretty close to the to the model. Does that make some sense, people? Because what I'm going to do is, if that makes some sense, I'm going to do one more sine model. And once I've done that, I'm going to actually stop this video and I'm going to let you guys practice this. And remember, your teachers should give you access to this kind of task for you to do. Remember, from Tuesday, you should be writing the properties, and today we're writing the fit. And these two, they might look like a lot, but it's not very much to write. And I've been doing a lot of chat, but this is one sentence, two sentence, three sentence, four sentence. It's not very long. And then this is one sentence, two sentences, three sentences, if that. And so they're quite easy to write, as long as you know what kind of things you're looking for. Let's go do the sine model and see what we can say. Pong, you need to stop putting croissants on there. Okay, cosine, sine model, here we go. F of x, sine of x. All right, ooh, I forgot the parameters. A, b of x. Right, once again, I'm going to make b. Okay, 2 pi on t. Okay, and so now I'm going to just choose my sliders. And I know that I've got 100 to go, so I'm going to make this maybe 200. Okay, and then A, I'm going to pick the highest. All right, and I'm going to once again put in projector mode. Once again, change this to orange and have a look. I'm going to zoom in a little bit, but I think my model is going to be quite good. All right, so what I'm going to do is I'm going to just make this a little bit bigger. I'm going to make it 15. I don't quite like it. I'm going to make it 16. That's too big. I'm going to go 17. Once again, I need to learn how to type. Oh, I know what's happened. I used to have an old keyboard, and I've just got a new keyboard, and this new keyboard does some interesting things. And so, it's quite interesting how this is about to go, because once again, just like my parabola model, I've got a really good fit from here to here, pretty bad fit up to here, and then I don't quite like this fit much either. I like it from here to here, but then it's pretty bad over here. Okay, and so for me, I want to be able to write comfortably about fit, and since I can't pick this value, it's okay. But maybe you want to try and plot a point. I might do that. 50 comma. You don't need to do this, but I just want to. I want to see what that point is, because that's been bothering me. And that point there is about 15. So that's meant to be 15, and that's at 17. So it's a difference of 2. And so I could also comment on that. Let's do that. I'm going to use that as my point. So here we go. The fit of my sine model. Ooh, I just realized I wasn't in notes. The fit of my sine model is good between x equals 0 and x equals, what's that? What do you reckon? I'm going to say x is 22. Which is, no, 25 maybe. 25. Got to read the scale carefully. This is because the, alright, full stop. This is because the model follows the roller coaster very closely The model is also good from about 75 to 90. Nah, 75 to 100. From x equals 75 to x equals 100 for the same reason. Okay? The model has a really bad fit from x equals 25 to x equals 75. This is because there is a large gap between the model and the roller coaster. Okay. Once again, that's an achieved level comment. I'm going to add to it to make it merit, and I'm going to say, well, first off, let's just quickly see, and we're going to go f of, what do we got? 15? Okay. And so this can be seen at the point x equals 15. Now, I'm purposefully trying to rewrite how I write this. You don't have to write the same words as me. I'm trying to change it up a bit. The model is at 7.72 2dp, and the roller coaster is at 8 with a difference of only what is it? 0.28. When this is quite small. When x is 50, the model is at 17, whereas the roller coaster is at 15. This difference of 2 is quite large and supports the fact that the fit here is bad. All right, so that's 3 fits that I've written. Pong, to answer your question, is there excellent answer for these questions, or are these just merit questions? I think the idea of what we're doing here, the fit, they're all kind of merity ideas, and so I don't want you to think of them as excellence ideas just yet. Okay, so think of them as merit ideas because you're describing fit and how that fits together. Excellence is a little bit more intense, and we'll talk about that when we're back at school. Your teachers will talk to you about that. And what I'm looking for and how you can generalize is what I'm looking for in excellence. And so don't worry about that for now. Okay, do you all have any questions with these kinds of fit statements? I'm going to leave these up, or I'm going to leave this up for you guys to quickly have a read, but please come back to this video to watch and to look at this fit comment and see how I've done that. Okay, it's all about having a look and having a play around. Yes, it doesn't look like it fits perfectly, but we can see a clear difference here, whereas here it's quite small. No, Rohan, that's a silly question. Fantastic. Does anyone have any other questions? Okay, Pong, you need to stop putting like weird things in here, mate. I'll just leave it open for. Yeah. So Joshua, yes, you need to do the properties like yesterday, like Tuesday. Yeah. So this conversation, this question or this video is really um, to highlight how we want to talk about fit. You will still need to do properties. Um, you will still need to do properties, and um, when you finish writing your properties, then you write your fit. So that's what I want to emphasize. So you write your fit after you've written your properties. But I didn't want to do both of those ideas in one video. Does that make sense, Joshua? So yes, you will still need to do the properties, but not now. Well, yes, but I was trying to focus on fit, right? Are we always doing it on Desmos? Yes, right. For the purposes of what we're doing, yeah, we try to use Desmos in our course. All right, I'm going to end the stream now. Hope you guys all found that useful. I'll talk to you later. Let me know if you have any more questions.